In this chapter, we're going to study trigonometry. In this lesson, we're going to look at multiple triangle problems.
Okay, everybody. So in this lesson, we're going to take a look at multiple triangle problems, which is really what we've been building to the last few lessons here, is dealing with trig problems that are going to be more complicated simply because of the scenario that's being described. Now, I know from our notes here, we jump right into a demonstration because, quite honestly, that's really what you got to do. We just got to start doing some questions here. But the one little bit of I guess advice that I can give you, and this isn't true for all problems, but it's true for a lot of them. What you want to do here is you want to find the side or angle, because it really could be either, shared by two triangles. Okay. Usually if you can find that piece that's being shared, normally there's a bit of information that you're given in one triangle that's enough to find that shared bit, and then once you know that bit, you can move into the other triangle and then work to solve whatever it is that you're ultimately being asked for. And that really is the procedure that we're going to follow here. Anyway, so let's jump into a couple of examples just so you can see what it looks like when we answer these kinds of problems. Okay, so in these couple questions here, we're going to determine the value of x in each of the following. So I'm going to zoom in here. I'm going to zoom in here a little bit. Okay, and make sure we have a good look at that here. So we've got two triangles butted up against each other, and it's the side BD that's common to both of them. So that's where my focus is going to be. I want to get BD. That is going to be the link between these two triangles. I'm looking for x. Okay, in this triangle right here, I've got two bits of information. I know this angle is 90, I know this angle is 48. That's not enough to solve for anything that's missing here. I need at least 3 bits of information. But over here, this triangle has 3 bits of information on this side. I know this angle is 90, I know this is 40, and I know this is 3. Okay? So I can actually solve something here. Now, let's call this side here y. This angle is the one that's important because it's the one that is the kind of the focal point here. I've been given this angle. So this one helps me define the pieces here. I know that side must be opposite, and this side here must be the adjacent side. So now I got to think, okay, when I know an angle, what trig ratio relates the opposite and the adjacent? And really, everybody, you just got to memorize that. You're going to have to spend some time looking at that list there. Okay, but this is going to be tangent. So I know that the tangent of 40 degrees, the calculator will know what that ratio is. It'll spit out the ratio of what this side to this side should be. And so that's going to be y over 3. And then I'm going to go to my calculator. I'm going to let my calculator tell me what that is. So the tangent of 40 degrees. Okay, and remember what we said before, if we go to 4 decimal places, that's probably good enough. Now I'm going to end up using the whole value here when I calculate it, because I'm going to let the calculator do that work here, but normally 4 decimal places, so 0.8391. So 0.8391 is going to equal y over 3. And I could turn that 0.8391 over 1 to a fraction, we go over 1 here, and I'll cross multiply. So y is going to equal 3 times, okay, 3 times that answer right there. So 3 multiplied by the answer that I just got, and to 1 decimal place I'm going to get 2.5. Now I'm going to leave that number again in my calculator. Okay, I'm going to come back and grab that number here in just a bit, but for right now I'm just going to write it down as 2.5. So 2.5 meters, that's the length of y here. Now I've got 3 bits of information in this triangle right here. So here's the angle that's important. I know now I've figured out the side opposite to it, and I'm looking for the hypotenuse. So what trig ratio relates the opposite and the hypotenuse together? That's sine. So the sine of the angle that I'm given, 48 degrees, is going to equal that 2.5 over the hypotenuse x. Well, my calculator can tell me what the sine of 48 should be. Sine of 48, that ratio of opposite divided by hypotenuse should be 0.7431. Okay, so 0.7431. Oh, did I round that right? Yeah. Over 1 is going to equal 2.5 over x. Now I'm going to cross multiply, and I will get x multiplied by 0.7431 is equal to 1 times 2.5. And now I'm going to divide. I'm going to take, and it'll be x equals 2.5 divided by 0.7431. In this case, I have to multiply because I ended up multiplying the variable by a number, not 1. Now, on this calculator, I can actually do this to a degree of precision that some calculators can't do. So what I'm going to do is I'm going to go up here and I'm going to grab this number right here. When I press enter, it pulls it down. And I'm going to divide that by this number right here. And again, I just use my arrow keys to go up and highlight it, press enter, and it puts it down right there. So now when I press enter, when I round that, I'm going to get the best possible answer I could get here, okay? And I'm going to get 3.4. Okay, approximately 3.4 meters. So there we go. So again, the procedure here that we got to follow is we want to find that line or that angle, whatever it is, that's being shared by the two triangles. So let's take a look at this next one here. Same question, but it's the next example here. I'm looking for this x right here. Now that x is just, okay, is just going to be this bit right here. It's not the whole thing, it's just that CB here. Now, that is not part of a right angle triangle. Okay, that triangle right there is not a right angle triangle. So I'm gonna have to get a little clever with this. Now, the bits of information that I have here is I know that this is 80 degrees and I know that this is 90 degrees. Now, that means that this little angle left over here, okay, is going to be 180 minus that 90 minus the 80. Well, that leaves me with 10 degrees left over here. And I'm told that this is 15 degrees. Okay, so what I've got here is I've got really two triangles that I'm concerned about. I've got this large triangle right here. Then I've got this smaller triangle right here. These are both right angle triangles. This one up here isn't, so I'm not going to be able to use the trig that I have right now to solve anything in this triangle. But I have a big triangle and I have this little triangle. So what I'm going to do is I'm going to use trigonometry to find this side, okay, CA from top to bottom. Then I'm going to use a little bit of trigonometry to find this side right here, okay, BA. And if I subtract that length from that length, so basically here's that length CA. If I subtract BA, I'll be left with that length right there. Okay, so let's look at the big triangle first. And actually, I'll use blue to kind of be consistent with this. So in this big triangle right here, this angle is the one that I'm given. 15 and 10 together, that's 25 degrees. I'm looking for the opposite side. Let's call this Z for right now. I'm looking for this side here, Z. And I have this side right here, the adjacent side, 45. So I'm looking for the opposite, and I've got the 45. So that's going to be tangent. So let's move over here. So the tangent of 25 degrees is going to equal Z over 45. Well, the calculator knows what the tangent of 25 is supposed to look like. Okay, the tangent of 25 should be 0.4663. Okay, so 0.4663, and I'm going to put that over 1, is equal to Z over 45. Now, we're going to cross multiply, but this is going to work out beautiful because it's going to be Z times 1. So Z is going to equal 45 times 0.4663. So I'll just multiply 45 by my answer from above. And I'll get, well, to the nearest tenth, I'm going to get 21.0. Okay, so 21.0 meters. Awesome. Now, I'm going to switch colors here. We're going to find y. So I'm going to focus on just this little triangle right here. So in that triangle, and maybe I'll do it over here, I have got this angle here, 10, which makes me label this as the opposite. This is the adjacent, so this is going to be tangent again. So the tangent this time of 10 degrees, is going to equal y over, once again, 45. Well, the calculator knows what the tangent of 10 is supposed to be. Tangent of 10 is going to be 0.1763. Okay, so 0.1763 is y over 45. And I'm going to make that 0.1763 over 1, just to make that easier. When I cross multiply, again, that's going to be a nice thing to do here, because it's going to be 1 times y, and then 45 by that, multiplied by that result here. So 45 multiplied by that result that I just got. And in the nearest tenth, I get 7.9 meters. Okay, now, to finish this question off here, all I really have to do is find the difference between those two. So my x here is going to be, now it's going to be ultimately 21.0 minus 7.9. Now I'm going to go up here to my calculator though, because I've got those numbers in here. I'm going to go up, arrow up, I'm going to grab that number, and then I'm going to subtract that number, and I get 13.0. Okay. 13.0 meters. Now, just watch this. If you go 21.0 minus 7.9, it's not exactly the same thing. That's because there was a little error that was introduced. When I do the rounding, I introduce this little error, okay? Little error here, and when you start to add and subtract them, that error just gets bigger and bigger with every operation that you apply there. So that's why the answer is slightly off here. So we would prefer that you did it like that. Okay. Now, when I'm marking stuff here, I'm going to be fairly kind of forgiving of that. I do want you to pay attention to the rounding here, but I get that some people have got different calculators and it makes it a little bit more awkward to work with. So that's okay. Just do your best with this. Set it up as much as you can. Show me the work though. Make sure that when you're handing stuff in that I can see the work here. And I suspect that would be true for most of you that may be looking at this. Your teachers are really interested in you communicating how you're thinking it through. Okay, so this stuff here is really important. Okay, this question here, this is a classic multiple triangle trig problem, okay? From the top of a smaller building, the angle of elevation to the top of the taller building is 25 degrees. Okay, let's talk about that. So what we mean by angle of elevation, we'll compare that to angle of depression here. So here's you standing right here on the ground, okay? And this is the horizontal from your eye. So you are looking straight ahead here. The angle that you might rotate your head up, like if you kept your eyes stationary, you didn't move your eyes and just kind of rotated your head up to look at something up, this is the angle of elevation. If, on the other hand, you have to tilt your head to look down at something, that angle that you tilt your head down from the horizontal, this right here is your angle of depression. Okay? That's what we're talking about here. So just to make sure that bit of vocabulary is okay here. So in this particular problem, the angle of elevation to the top of the next building is 25 degrees. The angle of depression to the bottom of the next building is 40 degrees. And we're told that the buildings are 32 meters apart. We want to know how tall this building is. Okay, well, what we need to do here is figure out the pieces of the two triangles here. So now I'm going to grab a couple of different colors here. So what we need to just start off with is we've got these two right angle triangles here, okay? We do know the distance in between them. So this is not exactly like I was telling before about these multiple triangle problems, and they're not always like that where you have to find the piece in between. It's just that most of the time they are. Here, what I need you to do is I need you to use the piece that's in between to find, let's say, this height right here. We'll call that x. And then what we need to do is find this distance right here in this triangle. We'll call that y. And when we add those together, that will give me the height of the whole building, and we'll call that z. Okay? So now, let's look at the top triangle. The angle that I'm given is this one right here. That helps us define the sides. I'm looking for the opposite, and I know the adjacent. So what trig function helps me with that? Well, that's tangent. So the tangent of 25 degrees is going to equal x over 32. Okay, well, the calculator knows what the tangent of 25 should be. So the tangent of 25 is 0.4663. Okay, so 0.4663, that's going to equal x over 32. I'm going to write that as 0.4663 over 1. I'm going to cross multiply. And then I love when this works like this, when that variable is up in the numerator, because 1 times x is just x. And then I just multiply those together. So I'm going to take that number right there, and we're going to multiply that by 32. If I just press multiplication, the calculator knows that I mean I got to multiply that, the last number that I worked with. So I'm going to get 14.9. Okay, roughly 14.9. I'm going to leave that number in my calculator so I can refer back to it. Now, we're going to look at the bottom triangle, the blue one here. Here's the angle that I've been given, 40 degrees. That helps me define this y here is the opposite side. And then that line across there is my adjacent. Okay, all based on the position of that angle right there. And so now, the tangent of 40 degrees is going to equal the opposite over 32. I mean, this is the same setup as before here. That's what's nice about this building problem. So now I just need to know what the tangent of 40 is. So 0.8391 if I round that. So 0.8391. And so this is what I was talking about before here. There's always this little bit of rounding that's got to occur, right? In this step right here, this was a little bit more obvious because I actually had to round up. But it always exists there when I'm trying to write the numbers down. Now when I cross multiply, again, 1 times y is going to equal this value here multiplied by 32. So 26.9, again, a little bit of rounding. And now what I want to do is I want to add those two numbers together. So the z that I'm looking for is going to be 14.9 plus 26.9. But I'm going to go to my calculator, and I'm going to go grab those numbers. So 14.9 right there, plus 26.9. And here I'm going to get 41.8 meters. Now, just out of curiosity's sake, let's just take a quick look here. If I had gone and went 14.9 plus 26.9, look at that, I get 41.8. So, I mean, sometimes it does work to use those smaller numbers. Sometimes it puts you a little bit off there. Okay, good. Okay, everybody, so this next question is going to be just a little bit more complicated than the ones we've just done. A hill, BD, 75 meters tall here, okay? The angle of depression to point C is 45 degrees. Okay, so that means this angle right here is 45 degrees. Now, there's my right angle triangle right there. Now, this part right here, BDA, okay, you're supposed to interpret that as a triangle in a sense coming out of the page. So just give me a second here. And what I'll do is, what we mean by that is, it's basically like this, okay? So there's your triangle, and then we've got this other triangle coming up out of the page here, okay, from B to here. So, whoops. So think of it like this. You're on the top of a hill here. Maybe you're looking east towards this point, and now you're looking south towards this point right here. And the angle of depression to A was going to be 40 degrees. What we want to do is figure out how far apart A and C are. Well, in this triangle right here, and this is the triangle that's basically down on the ground. It's from the point directly below the top of the hill out to these 2 points right here, okay? So it's this triangle that's essentially lying flat on the ground here, okay? It is hard to get your head wrapped around here. You might think of this as like a corner of a room. Okay, if you're facing the corner of a room and you look up, it's, well, if you had a room that was this big, 75 meters up, and then if you look to your left along this line of the wall to that corner, and then look to your right, this line of the wall to that corner. And we want to know basically what the diagonal distance is across the floor. If we were in class, it would be easy to kind of point to the corners here and help explain that. But this is like the corner of a box, and I'm trying to figure out the distance between these two corners. So what I'm going to do is I'm going to use these two triangles here, and they're both right angle triangles, even though this one, the diagram doesn't look like it. It's about perspective there. So for this triangle right here, if this is 45 degrees, then I know what this angle has to be inside the triangle, because remember, it's 180 degrees to flip all the way from pointing this way to pointing this way. So half of that is this 90 degrees. I know that these two angles here, this angle and this angle here, have to add up to 90. So 90 minus 45 means that this angle inside here is also 45 degrees. Same thing here, inside this triangle right here, I know that if this is 40, all I have to do is go 90 minus that 40, and that tells me that this angle inside right here has got to be 50 degrees. So this angle is 45, this angle is 50. Now, what we're going to do is we're going to find the two sides here. We're going to find DC, okay, and we're going to call that Y. And then because X has already been chosen, I also have to find this side right here. I'll call that Z. Okay? Just for clarity's sake right now. Now, let's find Y. So in that triangle, I have this angle, which helps me identify the pieces. I know that the Y side is opposite, and I know that the 75 is going to be my adjacent, so this is tangent. Now, at this point here, you'll probably notice that, man, tangent comes up a lot. And well, yeah, it does. In a lot of word problems, it does. And the reason for that is because sine and cosine both rely on the hypotenuse. And in a lot of real-world applications, the hypotenuse just isn't really easy to solve for. Okay, it's not a side that you would naturally measure. Whereas the two lengths of the along the perpendicular, those typically are relatively easy to measure. Okay, so this is going to be the tangent of 45 degrees is going to equal y over 75, whoops, not 75 degrees. I don't know why I did that, 75 meters. Okay, so just going to get rid of that right there. Now, I go to my calculator because my calculator knows the tangent of 45. So the tangent of 45 is 1. Well, that's kind of nice. I like that. So that means that's just 1 here. Now, if I write that as a fraction, I get 1 over 1, which means when I cross multiply, this is awesome. That means y is equal to 75 meters. Okay? So right here, 75 meters. Well, that was easy. I like that. Now, let's take a look at the next one. This triangle right here, we were given that this was 50 degrees. Side Z is opposite. So that's what I'm looking for. And again, my adjacent side is 75. So once again, this is a tangent problem. It's just that this time the angle is 50. And so that's going to be Z over 75. Now, I don't anticipate 50 having a nice tangent. 45, that was beautiful, but they can't all be like that. And there it is. Okay, so 1918. 1.1918. I'm going to write that over 1 is equal to Z multiplied by 75. Well, in spite of the fact that the tangent of 50 is not a particularly pretty number, 1 times Z, when I do my cross multiplication, that's just going to be Z, and I like that. Now I just got to multiply this number by 75, and I get 89.4. Okay, now I'm not done yet though. So what I've got here is, right, and this is 89.4 meters. What I've got to do now is figure out what the length of X is. Okay, well, X rides along the hypotenuse of this triangle. Now notice I don't know any of the angles in that triangle, but that's okay because I know the two sides. So I can use the Pythagorean theorem. In this case, the y squared plus the z squared is going to equal x squared. So y was 75 squared plus z, which will be 89.4 squared, that's going to equal my x squared. Now I can do this all in one step on the calculator. I'm fairly confident in that. I can take this number right here and square it. I'm just going to press the square button. And the calculator knows it goes back, it takes this, it squares it. I'm going to add to that 75 squared. I'm really happy that that number turned out to be so simple. It was just 75. Press enter, and I get this horrible big number. So this is 13614.1, let's just say, is equal to x squared. And now what I got to do to get my answer, because it's x squared, I got to square root it. 13614.1 is equal to x. So we're going to square root the answer. And here I get 116.7 meters when rounded to the nearest tenth. Okay? So a fair bit going on in that problem. But I think the biggest problem with this question here is really just getting your head wrapped around like what's going on here, what this scenario is. The triangles are pretty easy to work with once you've got that established, but to interpret this question in terms of what it's supposed to represent, that's the tough part with this problem. Okay, now we're going to take a look at this last problem here. And it says the line segment AD goes straight across a river, and the line BD goes straight up a cliff on the other side of the same river. So we measure the angle of elevation from point A to the top of the cliff to be 75 degrees. We walk downstream about 100 meters, and then what we do is we look horizontally and we measure the angle. When we look back at A, we measure it out to that same point D that we used before to measure the angle up the cliff there. And we get 30 degrees. Now, again, this question would be a lot easier to talk about if I could draw this picture out on the board here, make it a little bit easier and we will talk that through. But I think I can do this here. So basically what we've got is this triangle right here. Here's the river. Okay, let's say that the river's flowing this way right now. And then I've got this cliff on the far side of the river. Then what I do is I walk down. Okay, I walk along this, along the side of the river, stop, and then I look back, and I measure the angle this way. Okay, so what this problem is saying is that when I looked up, and I'll use blue here, okay, when I looked up, I saw that this angle here was 75 degrees, okay? I am trying to find this side here, and they've called that X. Well, I don't have enough information in that triangle. So then what I did is I walked along the side of the river, and I measured this out, and I discovered that this was 100 meters. This was my right angle. And then when I looked back and measured this angle, I got that this was 30 degrees. Okay, sorry, right there, 30 degrees. Now, what I want to do is this side right here is the side that is shared by these two triangles. So I want to find this side. Let's call this Y here. So in this triangle, because this is the angle that I know, this is the opposite, this is the adjacent. So I'm going to use tangent again for this particular problem here. So the tangent, I'm looking for this side right here. We'll call that Y here. So the tangent of 30 degrees is going to equal Y over 100. The calculator will tell me that the tangent of 30 degrees is 0.5774. 0.5774. Make that over 1. And when I cross multiply there, I'm just going to end up multiplying that by 100. So I'm going to get to the nearest tenth here, 57.7 meters. Okay, so now on this triangle that's along the ground here, this is going to be 57.7 meters. Well, that is the same length right here. So this triangle right here is now 57.7 meters, but this is my vertical triangle. So now I'm going to ignore the horizontal one. Now what I want to do is figure out the height of this triangle. Here's the angle that I was given. I'm looking for my opposite, and I know that that side that I've just been working with here is my adjacent. So this means right here that the tangent of 75 degrees is going to equal x over the adjacent side 57.7. Okay. The tangent, whoops, sorry. Oh, yeah, that's not what I wanted to do here, but that's okay. So the tangent of 75 is going to be 3.7321. So 3.7321, make that over 1, will equal x over 57.7. Okay, so I'm going to cross multiply here. I'm going to get x equal to the product of those two. Now, basically what happened here is I lost that number. I pressed the wrong button on the calculator. So I'm going to multiply that by, I pressed enter. Well, that's okay. It gave me the same number. I want to go multiplied by, and I'm going to have to do that calculation that I just did a couple seconds ago, which was the tangent of 30 multiplied by 100. So that's what I did a couple seconds ago, and I want that answer multiplied by this one right here. And now I get 215.5. And that's how tall that is right there. I didn't mean to press that enter button, and I got rid of the calculation that I did before. So that was a little more awkward about the way I finished that off there, but you get the idea as to how those triangles are related. Once again, it's getting your head wrapped around the diagram or the description of the problem that is really the issue here. The triangle work is usually pretty straightforward.